Hello to all, and I'm going to present the work done under FP5 on the efficient water management through multiple cropping system and subsurface drip irrigation. So if just look on the water balance of the Punjab state, if we see here in the green, that this is the available water from the all sources to the Punjab, maybe from the dams, rainfall, treated water, return flow. So that figure is come to be 53.06 BCM. And if we look on the below in the blue, that is the water requirement from the all sector. So agriculture having the leading demand of 62.58 BCM. So total demand is 66.12 BCM and availability is the 53.06. So there is a gap of 13.06 BCM, which currently Punjab is meeting through the drawdown water 5.10 BCM, withdrawal from the deep aquifer 7.9 BCM. So this 13.06 is the overdrafting of the water. So researchable issue is here that the at present our irrigation efficiency is 14%. So if you see on the bar diagram, the demand is 62.6. This is for the agriculture sector and availability is 53. But if we increase our irrigation efficiency from 40 to 60 in the blue bar diagram, our demand will be decreased to 50.1 and availability remain the same. If then we will get the sustainability. So this is the scenario that we have to have the saving of the 13.06 BCM of water. So taking into account these under the Tigris, we plan and experiment on the three objectives. Number one is the water budgeting of the existing and alternating cropping systems. And so that we can find out the water efficient cropping system to alternate the existing one. And second one, the assessment of the efficient method of irrigation for higher water use efficiency, as we have to increase our irrigation efficiency. So number third, the optimization and standardization of the surface or subsurface drip irrigation in the selected cropping system. So for that, to meet the objectives, we choose the 6 cropping system along with the rice wheat. So 7 cropping system are tested with the 3 method: conventional, surface drip, subsurface drip, and 2 level of irrigation, deficient irrigation and full irrigation to both rice, wheat, and the other upland crops. Those are tested in our cropping systems. So this is the source efficient cropping systems. We can see the laydown of the surface drip irrigation lines, and the below is the subsurface drip irrigation lines, along with in the center, that is the flood irrigation. Subsurface drip irrigations are laid down 20 centimeter below the surface with the machine developed by the PAU to lay down these dripping lines. So if we see the rice equivalent yield of all the 7 cropping system, the third one, the rice, potato, spring maize, 3 cropping system with 300 cropping intensity give the maximum rice equivalent yield. And second is the maize, potato, sunflower, and the basmati, wheat, summer moong, maize, wheat, summer moong, maize, pea, spring maize, and cotton canola. These last 4 one at par, but all the 6 cropping system perform better for rice equivalent yield than the existing first rice wheat cropping system. So if we see the irrigation water applied in these cropping system under different methods, the 2 green, light green is the surface drip, and dark green is the subsurface drip, and the red one is our traditional flood method. Though in the last slide, the rice, potato, spring maize yielded the highest, but if you see the water requirement, that is also the highest. But if look on the last cropping system is the cotton canola, so it saves 50% water than the flood rice wheat system. So it ranked first in the water saving. Second is the maize, wheat, summer moong, or maize, peas, spring maize, or the maize, potato, sunflower. But if we look into the next is the net return. Net return is again highest from the rice, potato, spring maize, because this is the 300% cropping intensity, 3 crops in a sequence. So we get the maximum return. And if we see the dark green one, it gives the highest return, that is the subsurface drip irrigation. So if you see now the cotton canola, it now ranked third after the rice, potato, spring maize, and the maize, potato, sunflower. So here it gives the good returns than that of the rice, wheat. So this can be a potential candidate for water saving, and the subsurface drip irrigation is proved best for net return and water saving. So if you see the performance, here you can see the performance in the decreasing order, starting from the first give the highest net returns, and then it decreased, and lowest was for the maize, peas, spring maize. So rice, wheat is coming second from last. So here is rice, potato, spring maize, or cotton canola. Cotton canola is the best because it requires less water. So these are the salient findings. The highest net return is from the rice, potato, spring maize, and drip irrigation result in 34 to 46% water saving over flood. And if we see the subsurface drip irrigation in cotton canola, so it result in 24.5% higher cotton yield, 15.5% higher canola yield, and saving of 50% water in cotton and 27.5% water in the canola as compared to traditional conventional flood method. So that is all from my side. Now Dr. Kapoor will present from his part. Thank you.
Hello everyone, I'm Dr. Sandeep Kapoor, and my presentation is on diversification in Punjab and interplay of farmers' income and sustainability. My colleague has already mentioned to you about how we are considering the irrigation, three irrigation pattern, that is flood, surface, and subsurface. So my presentation tour is like this, that I'm going to first present the current agriculture situation in Punjab, agriculture and animal-based economy, shift in the area and different cropping, different crops. Then what is the future diversification plan, and what is the income sustainability and markets. So first situation we are going to discuss is as a situation. So this particular slide shares with you the agriculture GDP per hectare of gross cropped area. So highest being Andhra Pradesh, which is able to get about 350,000 rupees, little more than that, as compared to Punjab, which is about 150,000 rupees per hectare. So Punjab is falling way behind, approximately number 12. So we need to improve the productivity or GDP per hectare. So if you see that, I'll give you a quick route of what is our GDP of the total state. Approximately, this is 555,000 crores, and out of that total GDP, the agriculture GDP is about 130,000 crores, which is about 23%, and it has come down from 1980 from 48% to approximately 23%. And look at the GDP of the share of the livestock, and look at the share of the crop. The crop is continuously coming down, and it has come down from 70% to about 59%. And the share of livestock has moved up from 30% to roughly about 41%. So if you see the trends in the livestock population, again, we are, the trend is on the upward side. Look at the cattle, and from 33 lakh heads, now we are about 25. The reason for decline here is that a lot of unproductive animals are being removed from the system. Similarly, buffaloes, you will find almost the same, although we touched in between something really high, about 61 lakhs. Similarly, the population is of goat and pigs is that is increasing. But one thing we need to see is that despite decrease in the animals, there is increase in the GDP from the animal side. So animals are playing a significant role. Here, more animals are grown primarily for milk and milk products rather than for meat and meat products. Of course, poultry is there for meat, meat and eggs. Although there is a significant increase over the last few years. So shift in the area, I'll just, we all know that rice is a predominant crop with about 3 million hectares coming under rice and 3.5 coming under wheat, and these areas are pretty low like maize. Significant I would like to see is the area which is covered under two basic crops. One is called cotton. So we have just about 250,000 hectares under this, and in oilseed particularly 34,000. So this needs to be improved, and we need to see as to how we are going to go about it. So what is the 2B situation? So in 2B situation, we are looking for four basic parts: sustainability, increase in farmers' income, market friendliness, and ease of growing or stability. Now, a quick look at how the food expenditure of Indians is going to change. So we say in one of the studies which is conducted by McKinsey CII, which says that, of course, fruits and vegetables followed by milk and milk product. That is what we see a major increase that is changing here. In others are basically, you find a bigger change from 22 to 26%. This is primarily beverages and salt and other things. So we see a big percentage increase in vegetable, fruits, meat, and milk. And whereas growth of pulses and cereal is going to go down. This is what is protected. So we have only two products, two alternatives where primarily one is a high value crop that we shift to, or with the animal based products we shift to, or we have products having a real long value chains. So I'll quickly see that look at the area in fruits and vegetable. We have not been able to grow significantly in the fruit area, but yes, in the basmati, which takes lesser water as compared to rice. So we need to focus on that. So I'm going to share with you. This is the slide my colleague has already shared, so I'll not go. My focus here will be from grain to oil to the animal economy, and this is the slide which I would like to focus for a minute. It talks about that cotton canola. This in blue, it is the irrigation water requirement in and this is a return over the variable cost, what we see here is that at 700 requirement, we are able to get the rice cotton canola system to be at 2170, which is higher than the rice wheat, but lower than few of the other cropping system, but we believe this is a strong contender for the same. So what I want to say is, but the other systems are also there, particularly subsurface drip, that is also there, where we are able to see higher cotton productivity as well as canola productivity. So our main potential areas are cotton, canola, maize, basmati, poultry, potato, dairy, and fruit and vegetable. So I'll share, this is a slide which I would like to focus on. We want to bring the proposal is to bring the area under rice from about 3 million to about 2.4, whereas wheat, it should go down from 3.5 to 2.7, whereas the major increase has to be in the rabi, particularly the oilseed canola, from 34,000 to 800,000, and cotton from 250,000 to 800,000 hectares. And within this, we want more of the non-basmati to further go down and basmati to go up by 850,000 hectares. So another point which I would like to make here is that with this kind of a system, India needs to, or Punjab needs to focus on few of the productivity linked, and we after a lot of discussions, I've taken this from McKinsey CII study, that present levels are 6 in India yield, and Punjab yields are 5 as far as wheat is concerned. So there are productivity improvement chances almost all the crops. So my conclusion here is the area under rice and wheat is to be reduced, and surface and subsurface drip irrigation provide better yields, but cotton, canola, and maize are the major contender, and we should focus on that. But we need to focus on value chains of each crop is required to achieve the desired result. With these words, thank you so much for patient hearing. Thanks a lot.